EdvoTech Tips: Quantifying an ELISA using ImageJ. In this video, we'll show you how to use technology to quantify the results of the enzyme-linked immunosorbent assay with just a cell phone and a computer. What is the ELISA? The ELISA, or enzyme-linked immunosorbent assay, is a technique that uses antibodies to detect specific molecules in a sample. It's widely used in disease testing, allergen assays, or protein expressions. ELISA results can be either qualitative or quantitative. Qualitative ELISAs give a simple yes or no answer. Think of a COVID or pregnancy test. In contrast, quantitative ELISAs tell us how much of the target is present by comparing results to known concentrations in a standard curve. The amount of measurable signal in an ELISA depends on the reaction between antibodies and the antigen. A signal can be detected and quantified in wells where this complex is formed. Some ELISAs need special instruments to detect the signal. EdvoTech's quantitative ELISA kits contain a chromogenic substrate that produces a visible color. We can easily measure the results with densitometry or the quantitative measurement of light absorption. That's where ImageJ and your cell phone camera come in handy. Let's get started by installing ImageJ on your computer. This is a free image analysis tool developed by researchers at the National Institutes of Health. You can find it at imagej.net. This tutorial was prepared with ImageJ version 1.54H, so newer or older versions might be slightly different. You'll also want access to a spreadsheet program. This could be Microsoft Excel, Apple Numbers, or Google Sheets. Set up your spreadsheet with the concentrations for the standard curve and the sample names for ease in recording data later on. Perform your ELISA following the protocol included with the kit. You should have experimental samples, control samples, and a standard curve. After incubation, take clear, shadow-free pictures of your results and save them as JPEGs. Next, we'll use ImageJ to calculate the mean gray value of each well. In digital images, each pixel has a luminance value, or light intensity, which ranges from black, 0 intensity, to white, full intensity. In ImageJ, this value is called gray value. The mean gray value is calculated by adding all the gray values in a selection and then dividing by the total number of pixels. Let's set ImageJ to calculate the mean gray value. Open the ImageJ program on your computer. Go to File, Open to open your image. Go to Image, Type, 32-bit. Next, go to Edit, Invert. Finally, go to Analyze, Set Measurements, and select Mean Gray Value. Next, let's select the wells. Choose the Round Selection tool and draw a circle around the first well. Go to Analyze, Measure. A new window titled Results should appear. This will display the sample number in the first column and the mean gray value in the second column. Record the results in the appropriate spreadsheet cell. Repeat this for all wells, including your standard curve and your controls. Now that we have collected our data, we are ready to create a standard curve. First, we will plot the antigen concentration on the x-axis against the mean gray value on the y-axis for each sample in the standard curve. When your data is in this format, create an XY scatter plot. Next, use the software to draw a best fit curve through the points in the graph. For best results, we suggest using the logarithmic trendline graphing software. The best fit line may not pass through every data point, and that is okay. Be sure to display the equation for your curve on your graph for reference. Once we have our standard curve, we can use it to determine the concentration of the target molecules in our unknown samples. There are two ways we can perform this calculation. For the first method, we will use the equation of the best fit curve to solve for the concentration. Substitute the mean gray value into the equation and solve for x. For the second method, print out your standard curve. From the y-axis of the standard curve graph, extend a horizontal line from this absorbance value to the standard curve. At the point of intersection, extend a vertical line to the x-axis and read the corresponding concentration. And that's it! You've learned how to quantify ELISA results using simple tools you may already have in your classroom. This approach lets us relate antigen concentration to light absorption, estimating unknown sample concentrations. Let's start quantifying ELISAs the easy way. Thanks for watching. We pride ourselves on providing the highest quality customer service for our teachers. Call, email, or send us a message on social media.